Now we want to demonstrate the usage of the Python package Powerindices. I suppose you've installed it already. If not, go to the GitHub website and find Powerindices. There you find instructions on how to install it. And once it's installed, you can actually run the command Powerindices, and it's not giving you any error. That means you're ready to go. So let's go. In order to use it, you have to type powerindices dot, and then you have access to certain functions. So that basically means, hey Python, look into the package powerindices, and there you find the function compute SSI, which is going to compute the Shapley Shubik index. And in order to do so, we have to specify two arguments, the quota and a list of weights. And the third argument is the minimal winning coalition size. It's optional and it's default set to 1. If you increase it, that means that all the coalitions smaller than the value that you send are automatically losing. For now, we want to consider a simple example. For example, a parliament where you have to pass a quota of 50%, and let's keep it simple. Let's say there's a party with 30% and another party with 30% and a party with 40%. A party with 40%, and it gives you an error. Why is that? Because the algorithm behind it can only deal with integers, but we send floats. No problem. We just take everything times 100 and we're good. Right. So the Shapley Shubik index just gives a third to each of these parties. Because they're actually symmetric, it always requires 2 of them in order to pass the quota. The other indices can also easily be calculated. For example, the Penrose Banzhaf index. This time, however, it's not going to sum up to 1. So it's the non-normalized, that's the absolute Banzhaf index. And there's also the Coleman Shapley index, which in this case also sums up to 1. Interesting. Okay. Let's go for a little bit more involved example. The United Nations Security Council, it consists of 15 members. 5 of them are veto states, the permanent states, and 10 of them are non-permanent. In order to pass a proposal, you have to have all the votes from these guys, and you need 4 votes from those guys. So in total, it needs to be a coalition of size 9, and well, these fellows here need to be included. How can we capture this here? Very easy. We just say, you need 5 votes, and the veto countries have a vote each, and the others, they don't. Like this. But in this case, you're not getting the desired result because those fellows here are null players. They're actually not needed in order to pass the quota. We can fix this, however, by okay, now I'm typing it down there. By typing minimal winning coalition size is 9, and now only coalitions of size 9 are winning, which turns these guys into non-null players, and we have the Coleman Shapley index for this committee, the United Nations Security Council. Just for demonstration, you can also easily calculate the Shapley Shubik index or the Banzhaf index. And you might have realized that whatever you get back is actually a list. And we can, of course, store it. We could say, let's store the CSIs. And, type CSI is a list. Yes, and as such, we can treat it and we can do all things that Python can do with lists. For example, we can sum it up. Why is that interesting? Well, because we have the following: the Coleman power of a collectivity to act is actually half of the sum of the CSIs. And this way we also have this number.